Hi guys, today I'm doing a recording on buffer overflow on the Windows operating system. We'll be targeting an HTTP service, a web server running on a Windows machine. The last time we did an exploit on an FTP application, so today we'll be doing that on a web server running on a Windows OS. Okay, so this is the attacker machine, obviously running on Kali, and this is the target machine, Windows operating system. And so the service that we are attacking is this is the name, well, the name and the version. So it's syncbreeze Enterprise 10.0.28. Okay. Oh boy. Okay, let's open. Alright. Okay, so a simple, what we do Google search. So it's syncbreeze. Okay, I've got it here already. So I do a search on Google looking for an exploit for this service. And there's quite a lot of them. So I go on this one from exploitdb, and so this is basically the POC, the proof of concept exploitation for this service. Okay, so the way the guys upload these POCs, it's just very technical. You know, most of them don't really, you know, like give you details in terms of what's going on here. So, you know, if you haven't been doing binary exploitation, you know, it can be a bit confusing. So okay, let's just break it down and see how you can use this to actually run the exploit. Alright, so this is a Python script. We're importing modules. The sockets, this is important for your for the networking activities that you'll be doing. And OS and system, it's if you want to run OS's command from here. Alright, and then we'll be defining variables. Okay, so from here already, I can see that the first crash is happening at 1000 bytes. This is the jump. So the jump to the stack, this will be, it will be a valid address in memory. Okay, that we'll use. Okay, these are the bad characters for when generating a payload for it. And this is the payload that it's got. When you go further down, okay, you see another crash, but this one crashes. So this is the latest one that the script will read, because the script reads from top to bottom. So you can see that, okay, we can already see this is the offset, this is the jump of the valid address. This is a little bit of no operation of NOPs, you know, to make sure that the attack eats your payload, you know, that you'll insert. And yeah, at last, this is your payload. This payload contains the CMD terminal injection, okay, on the Windows machine. And here we can see that because this is a web, you know, it's a web server, we see that this is where it's crashing it. So we've got a username. So we basically, there's a vulnerability on the username field. That's what this means, because this is where is inserting the crash, which is, you know, the payload and everything that we're sending. Alright, and down here, so this is the HTTP form, because I remember we'll be sending traffic to an HTTP server, so we need to send it in an HTTP format, and this is the HTTP format. use to communicate with the web server. In the end, you can see, so we've got a lot of options here, but at the end we've got this, sorry, where is it? Fuzzer. Yeah, so we've got this, which will be, so it will insert a username with the crash and the password. That's where this is happening. And then we're defining the network socket to actually, we're defining the network socket here, and we're connecting here. This is the IP address of the Windows operating system, the port, and we're sending the buffer, which is all this. Okay. All right. So that's pretty much how this exploit will work. So what we can do, we can copy all this. We'll bring it to our machine. We'll call this file. We'll create a file, fuzzer1.py Python script. Go in here, we put everything. Now let's just remove what we don't need. Okay, so I'm just gonna take all this off. Okay, I need the socket. I won't be running OSS command from here, but it's okay, I'll leave that there. Okay, this I'm gonna leave. This I'm gonna leave. This I'll delete, and then I can remove the payload because I'm gonna use my own payload that I'll generate. And then this I'm just gonna issue it out for now. When the file yeah, so what I'm gonna do, yeah, I'm gonna use that one. Let me just okay, let's leave it issued out for now, so it won't be read. Okay, and then we've got the crash username plus crash and all that. Okay, so we will be we'll be taking this off because I'm going to be running this for my machine. Okay, well I'll basically show you how we got this, how we get to this. So let's delete all that. Okay, and then yeah, okay, so let's just get the IP address of this machine. IP address is 101. So 6 101 80. Okay. Alright, let's just save this file for now. Then what we're gonna do, we need to open up another session onto the Cuddy machine. I just need to browse. Oh god. I need to browse through that to that web server. So to do that, I'm gonna, okay, let me just show you. Let's start Firefox. This. Firefox is coming up, just a bit slow. There it is. Now, from here, I can go to 102. Yeah, that's the address that I want to go to. Enter. Oops. Okay, yeah, because it's going through proxy. Let's open it from here. I should have access to it from here. Let's go. There it is. syncbreeze Enterprise version 10.0.28. Log in. Okay, now this is where the buffer overflow is. So what we're going to do, we'll come back here. No, actually, wait. Okay, we need to go through burp suite. Okay, to get the HTTP communication string that we'll use to communicate with the web server. So we need to have burp suite on. The burp suite allows you to intercept traffic between your browser and the web server. So it's gonna go startup, use default. Come on. Let's wait for burp suite. Come on, burp suite. Where are you? Burp suite is hiding now. Hold on. Yeah. Okay, you know what? Let's close it. Oh. No. Okay. Yeah, this is just my machine acting up. So let's close it. Then let's start burp suite again. Okay, next, start, and now you should work. Okay, come on, why are you doing this to me? Okay, just give me a second, let me fix it up. Okay, I managed to get burp suite open. So this is burp suite that you're looking at now. Yeah, let's just make sure. Yeah, proxy intercept is on. Good. From here we'll go there. So this will wait for me to authorize this. I'll go forward, and it comes back. Let's have a look. Okay, we go login. It's gonna wait for me to forward that. We forward it again. Let's have a look. Yeah, we forward it again. Forward it again. Forward. Okay. Forward. Oh, wait. Okay, so now we have the login page. So we're gonna put any random characters. Okay. And then we'll say login. It will wait for me. Okay, so you need to forward up until you get to where we can see the username and password. Wait. Okay, but already you get the idea of where we got the HTTP communication. It's from here, from this string. Come on, there it is. That's what we need. So from here we can copy all this. Come here. Yep. Okay. Alright, so now that we've got this is the HTTP communication string. We can copy that, put it in a file here, like this. Okay. Okay, actually, I'm gonna take it off, and then I can now put it in my fuzzer. Okay, I'll put it here. Now what we need to do, all of this needs to be part of the buffer. So we're gonna do this, buffer, and we close. For everything that we close, we need to enter. So if you come here, you'll see where is it? Yeah. If you come here, you'll see how we do it. So you see, for every new line, we need to enter a new line. So it \r\n. \r\n. Okay. So it's gonna be like this. Just that. \r\n. \r\n. Buffer. Yeah. Buffer equals. Close it. \n. Then \n. Buffer like that. Buffer equals like this. Close it. \n. And then do this. \n. And then we will do this here as well. Okay. Do the same thing here. New line. Now content length will be the length of will be the total length of the data that we're sending. So when you have a look here, you see the content length is this, which is the total length of that. Okay, so we need to do the same thing. At this point, I can do it like that. First, then take this off, put that in. Oh, and another thing that I was forgetting, we need to go plus equals, so that it adds. So we need to go like this. Yeah, that looks good. That looks good. Alright, so what he's saying is the offset is at 780, and he managed to get it by starting to fuzz at 1000 bytes. So what we're gonna do, we're gonna do it even better. So we will put we'll put a pattern here, which will create like this. With this command, use the share metasploit tool exploit pattern create -l 1000. This will create 1000 bytes, which we'll use to get the right offset. So come here, do this, put all of that there. So now yeah, so now what I'm gonna say, I'll say fuzz equal username plus crash. This is crash 1000. Okay, so we're putting it there. Now we need to do this to get the right offset, just to make sure that this offset is right. Okay, is everything okay? Let's have a look. Yeah, okay. Let's have a last look. Yeah, it looks okay. So now we can. Okay, so now we're ready to test. All right. Okay, so let's save it like that. Let's make this executable, and then we come here. We need to first have a look. The service is running. Okay, we know that it is, but this is where it will be running. There's it here, syncbreeze enterprise, enter. You can see it's running. Okay, good. Minimize that. Open up your Unity debugger. Attach. Sync. Okay, so we're loading it here on Unity debugger. Make sure that everything is good. Yeah, program is ready. Now we will execute. We'll execute this in the attempt to give us the right offset. Okay, so I'm gonna run this from the attacker machine. Boom. Let's come have a look. It is here. Okay, we see we've got when you look here, we've got an access violation at this address in memory. Okay, so now with that we'll get the right offset. So the command will be this. So as you have it here, exploit pattern offset to Rabi -q. Let's take this off. -q, and now you need to put the right. You need to put this memory address 42306. 42306 and 306 42306 142 minus L, the number of bytes that you sent. This will show you where the right offset is, and yes, it is exactly matching this offset here, so that's right. Now the next thing that we need to find, it's the GMP address, the jump address to the stack. And so we'll get the one, we'll get the address that is binded to the library that's running within the application. But we need to get the right one. We need to get, if you want to, if you want to exploit this this machine over and over, even after a restart, you need to get the library that's got memory randomization. Yeah, that's got the memory randomization option off. That's the one you need to get. So alright, let's do this. First you need to close all of this for now. Then you need to start this again. You need to restart it because it crashed. Then we start this as administrator. We go to file, attached. We attach the program. You want to debug. Start it, make sure that it's good. Then you'll come here, you'll type this command, mono module. Yes. Now this will list you all the interesting modules, and you're looking for modules that's running within the application, but that's got the memory randomization off. Okay, so let's have a look at this. So it's gonna have false all the way through. So this one's got false all the way through, and it runs within the application. Yeah, that's right. Good. So what we'll do, we'll do mono find string. We're looking for the string. We're looking for the string that's got the jump to the stack value, which is ff_e4. Sorry about that. So it likes ff_e4. Okay, and then we want to find this string from this module here, libsppdl. libspp.dll. Okay, enter. It's gonna look through this, and you can see it's found one, and this is the address. So what you want to do, you want to copy that. So let's just put it here. It's not so long. So it's 83.0c. Okay, let's try that. Go back here. So now, and you can see, yeah, look at the library that he's had. So it's the same library that we've got, and look at the memory address 83.0c0910. Where's ours? 83.0c0910. Yeah, it's exactly the same one. So we're on the right track. Alright, so what we're gonna do, okay, so now we can open this up. Okay, we don't need this one. So now we're gonna have, okay, we know that the offset is at 780, and this address here, this entire address here, it is the memory address here. That's good. Go back, that's right. And then you always have an ops after the jump, after the valid address, to make sure that you land in your payload. So we've got an ops of 16, which is fine. But now, before I put the code, I'm going to put something else called add, for instance. Okay, and this add, I'm going to define it here. Add equals, I'm going to put a seek trap just to make sure that we've got code execution. Okay, so I can send it like this. Let's have a look. Yeah, offset, we're jumping to the valid address in memory. We're printing some no operation, about 16 bytes, and then we've got our seek trap. Alright, so I can do that. I'm ready to launch. Go back to the server. I can close this again. Make sure I'm still running. I see it's off. It started. Service is started. Come here, open it up, touch it. Sync, yes. Okay. Alright, service is running fine. Now when we execute the script, we should get a seek trap. A seek trap is known as interrupt number 3. So you'll see interrupt 3 here. If we got it right. So on it, come back here. There we go. Interrupt number 3, and you can see it right here. So you can see these are our 41s. 41, it's A. Okay, that's the hexadecimal value of A. Okay, so we go A. So this is the 780 bytes that we have there at first. Okay, we come here all the way, and then we look at this address in memory. Remember, 830C0910. We're jumping there. These are the 16 no ups that you saw there, and right after that, here's our code execution. So we got code execution. This is good. So now we can safely insert our payload. So we'll close all this. Come back to service. Make sure that it's running. Okay, minimize that. Then, alright, so now we need to generate the payload that we're going to use. So you do a command msf venom. Okay, I've got it here already. So msf venom, I'm specifying the architecture, platform is Windows. The payload will be a bind. I'm not a big fan of bind payload because I don't control that side of the network, so the target could have firewall open, and that could cause a lot of issues. But for the sake of this exercise, we'll just use a bind PCP. It works well as well. And then we will listen to port 4321. This port will be listening on the target machine, and these are the bad characters that we want to exclude from the payload. Okay, and F for format, and this is a it's a Python payload. Okay, we will now generate it. Take some time. There it is. Tells us this is 1710 bytes, and this is the code. We'll take the entire code, and then we'll put it just before the crash. So let me put it here. Okay, there it is. Okay, so now the crash will be the A780. Jump to the valid address in memory, print some no ops. Instead of add, we're going to have buff, which is the code that we want to point to. Okay, so everything else stays the same. Files will be username. Yeah, to be username crash. Yeah, username crash, that's fine. This is fine. Okay, so we are ready to launch. Okay, gonna do this. Alright. So now you're gonna get ready to launch. Then we'll go to the server. Okay, at this point we don't have to open up Unity debugger anymore because we've gotten all the information we need to successfully exploit the machine. So we can just have the service running. Alright, so what we'll do, we will now initiate it. Okay, script has ran. Alright, so the script at this point, the script has injected the payload. Okay, and the way you can now connect to your machine, you can just go through nc. Let's do it from here. Let me just close all this because we don't need this anymore. Okay, so now, oh, I'm sorry about that. So now I can go to the server at the port, because remember this port, this is, let me show you the port again. This is the port that we specified on the payload, so we need to connect to that. So we need that, connect, and there you go. As you can see, Windows System 32, and I can do here. Okay, so right now we connected to this machine, and everything is running perfectly here. You know, here's the service still running. Service is okay, and you know the machine hasn't crashed. The user can carry on working. But from my side, I have got access to this machine right now. As you can see the DLL. I can browse around. So I've got complete control of this machine from this point on, which is great. Yeah, so basically at this point we have executed the exploit, and yeah, we've overwritten the buffer, and we are connected to the Windows server, to the Windows machine through this vulnerability. So yeah, I think we're pretty much done. Oh no, one more thing that I want to show you. Remember I told you that you needed to find the right library, the library that had randomization, memory randomization off, because that will allow you to regain access to the machine. We can test that now. You can restart this machine. Okay, machine restarting. My connection will bomb out. Right about now. Yeah, no connection anymore. I'll do this. I'm gonna wait for it to come back up. Machine's coming back up. There it is. Machine is backed up. Go back to my attacking machine. Execute my payload. Connect to the machine. Boom. So in this way, you basically own this machine for for as long as this service is running on the target machine. Yeah, that's about it for now. Okay, thanks for watching, guys. You can leave your comment, and yeah, you can leave your comment, suggestions. Okay, cool.